Hello, my name is Anton Glinkin. I'm Senior Application Engineer at CDT, and today I want to talk with you about setting up concurrent design. So today I cover these topics. What is concurrent design? When do you need it? What is the theory behind the concurrency? How to obtain optimal performance? Show some demos and give you some most frequently asked questions. So, what is concurrent design? Basically, it enables multiple users to access and edit the same project of ICDB. ICDB stands for Internal Common Database. It also uses RSCM, Remote Server Configuration Manager, to allow to combine all these digital threads from different users. RSCM server supports handling multiple projects at the same time, but also it allows you to have multiple releases of your software. So when you need concurrent design? Well, the most obvious thing is that when you have multiple users needs to work on the same schematic but different sheets. This is one of the limitations. You cannot edit the same schematic sheet altogether. When you have multiple users that need to work on the same PCB layout or constraint entry for the same design. Also, for example, for past professionals, sometimes your schematic and layout engineer wants to work on schematic and PCB at the same time. It's good to have if you have remote connection to office and you're working remotely, or you want to manage separate client sessions on the same machine. So, a little bit of theory. How does it work? Expedition workflow based on ICDB, as I told you previously. ICDB provides possibility to work on project for multiple schematic and all layout engineers simultaneously, like multiplayer game. For concurrent schematic editing is used RSCM. For concurrent layout editing, you need to use layout team server. So, specifically, the RSCM server runs two processes to support concurrent design: ICDB Net Launcher .exe and ICDB Net Server .exe. The first process is ICDB Net Launcher. The RSCM server runs only one instance of this process. The process runs continuously as a service on Windows and as a daemon on Linux or Unix. ICDB Net Launcher process listens for clients to request access to a project on port 9000. This is default port that can be changed in Server Manager. When it receives client request to open a project, RSCM server launches the second process to open the project and support concurrent design. The second process that the RSCM server runs is ICDB Net Server. ICDB Net Server, each open project that points to the RSCM server gets its own ICDB Net Server process. So it's one process per client or project. ICDB Net Server manages the client access to the data, and it requires not so many resources. As well as ICDB Net Launcher, it also requires minimal network resources because it simply manages ICDB Net Server processes. ICDB Net Server processes, however, may demand significant system resources depending on the size of your project, and an RSCM server can run up to 100 ICDB Net servers in default configuration, but this number can actually is limited by available system resources. If your system lacks capacity, you should plan for your RSCM server to support fewer ICDB Net servers. ICDB Net Server runs by default on diapason of 10,000 to 10,100. These ports also can be changed through the server monitor. From the other point of view, from the other side, we have team server that run by default on port 10,545, and team clients, and their default ports is 10,550 and 10,581. These ports are not configurable. How does it look like? Team server manages layout transactions from client, as you can see on first diagram. Then team server writes it to the master design through the RSCM server. You can also set the additional option that allows clients to maintain local copy of design For this, you need to create environment variable mgc underscore xdc underscore design underscore path, or you can just use the temporary directory. You can also use remote start if enable mgc extremenet host environment variable. Some important factors for optimal performance. First of all, first option is to have RSCM server, team server, and all project data on the same machine or in the same local network with strong, good connection. For RSCM server to design data connection, you need to have low latency, high bandwidth, especially for schematic design. RSCM server to team server, perfect option is to run them on the same machine. Team clients to team server, latency is the key. Bandwidth is not so important. Central library, of course, it's proximity to clients and fast file system because you have a lot of read-write operations. Another thing is primary or local working directory. Best to have it located on the client machine running design tools. And ensure that RSCM server, team server, and clients run on the same release and update. On screen, you can see recommended connection parameters to have best performance. So how do you set the project in order to run this concurrent mode? First of all, you need to create a new Expedition Designer project. For this, you start the designer, press File, New, Project, enter project name, set the project location, set the library location, enable concurrent design mark, enter name or IP address in the server name field, and press OK. Now you can close and reopen project on server. After that, second schematic engineer, or multiple of them, can open project on their side, and all users can edit the project now. How does it look like? First of all, we need to install the RSCM server through the RSCM configurator. There is a button, New Server, RSCM server. Default options will work for us. As you can see, we need to start the RSCM server. The green button shows us that it is currently working. Now we creating the project in Expedition that located on the directory that can be accessed for all users. Project location should have read-write permissions. The path must resolve to the same location from all client machine. We put the name, we select the library, enable concurrent design, and put server name here. In ICDB Server Manager, we can see that process was started and other users can join this project. Multiple clients can edit this schematic concurrently, but two users cannot edit the same schematic sheet. In this example, as you can see, we open a couple schematic sheets. And for second engineer, it will be shown as read-only mode with the name of the user who is currently editing it. This is the only limitation for concurrency in schematic. When the first user finished his job and closed the sheet, you can take the editing permission from it clicking this button. When all engineers close the windows, ICDB server will close automatically the server project. Now you can stop RSCM server if you do not need it anymore. If you want to delete it, you can uninstall it. From the other point of view, we able to concurrently edit the constraints. This is how it looks like. We have two users on the left and on the right side of the screen. This is standard thing. We create differential pairs. And another user will see something like that. When we create the new class, we can see that this new net class is marked with the lock icon. It means that this net class cannot be edited because somebody working with it. When the job is done, you can work with this. So you cannot edit the same entity, the same thing in the constraint manager at the same time, but you can work in different different constraint areas. The field is currently edited is marked with this special crossed pattern. You can also see who modified this cell. Let's talk about layout concurrency. To launch team layout session, you need the license, layout 201 or 301. Server should have rights to read and write to project files. All clients and server should run the same software version. And default ports that shown on screen should be opened. You need to launch layout team server, select a project, select data compression level, and select additional licenses that will be used during the concurrent session. Now all clients that will open the project will be automatically joined to your session. This is how concurrent design looks like in real life. We have three engineers here, three windows, three layout windows. And this is basically a multiplayer game when you see your own movements and you see actions of all other users in your session. There is no lag except the system, there is no lag except the ping, the server. And this is basically real-time strategy, I would say. When you need this, when you have a hard or big project that should be completed in a short time. There is no difference between 2D and 3D view. Each of you can work in preferable manner. You may see the circles around the mouse cursors on the left side of the screen. This is so-called forced area, and this area is protecting you as a user from interactions with other engineers. So basically, other engineers cannot do nothing in this area. On screen now you can see the sketch router, very nice, comfortable tool to use. It allows you to quickly route big bundles of nets. And it automatically unravel and making the fan out in optimal way. There is another type of concurrency in Expedition. I will not be talking about this today, but I just want to show you what is it. This is ECAT-MCAT collaborator, and this is the thing that allows you to synchronize your mechanical model and PCB project. In this case, we're working with Solid Edge. Don't mind that interface language is Russian. This video was recorded back in times when I was working in another place. So basically we have a basic, sorry, I'm talking very strange. We have basic shapes that created by mechanical engineer, and he wants to push this information to you to give you initial the board outline, mounting holes, and placement of some critical components. This can be done through the CAT-MCAT collaborator in Solid Edge, this panel called PCB, and PCB collaborator as well. You select the project location and library location. In library location, you have all models. Hit OK button and run ECAT collaborator. It's a very basic thing. You can choose which type of the file, the version of the format, units, and type of connection. There are two types of connection. You can send the EDX file directly or using the electronic mail. Then you hit the button to get all data. We start from the baseline. IDX is the incremental format, so you do not need to generate all information every time. You just add the changes from the previous one. Now we created the baseline and send it to the layout engineer. Layout engineer is working in Paths Professional. This is like preset default. So you can just go to 3D, MCAT collaborator, and you can see that there is new baseline file. All engineers to this, like layout and mechanic, can access the same folder. Layout engineer can preview all changes that proposed by mechanical engineer. He can go one by one. There is placement obstruct zones, mounting holes, and some electrical components set. Of course, you can partially accept these changes, not only all of them, because sometimes another engineer do not know that you have some limitations. So after these changes accepted, the response file was generated and sent back to the initiator of this process. It means that two sides of this process will stay in sync, and there will be no potential problem when you have different information in schematic, in PCB and mechanical model. After initial placement and board changing done, layout engineer can work on the layouting process, place the components, make some layout, and so on. I will skip a little bit. So we have some kind of placement. And we want to share this information with mechanical engineer. We select the proposal, choose which information we want to transfer to the mechanical side. Click the update tree data. We see all changes from the initial baseline, and we can send it to the mechanical engineer. New file was generated called proposal IDX. Mechanical engineer sees it. He can review all proposed changes and apply them to his own PCB assembly. Successfully finished. A response file was generated and we send it back. As you can see, get this response file. Now both projects are in sync. This is how we working. So there is some frequently asked questions. I will not be reading that because there are too much information, but you will see this on YouTube channel after I edit today recording and upload it to this YouTube channel. If you have any questions, you can ask them now. Okay, if there is no question, I will stop the screen demo.